Unit 2, Target D notes, taking square roots to solve quadratic equations. All right, example 1a, we have x squared minus 36 is equal to 0. In order to be able to solve this, we want to get the term that has the square by itself. So in this case, we want to get the x squared by itself. The minus 36 is in the way, so in order to cancel that out, we're going to add 36 to both sides. Okay. On my left, negative 36 plus 36 is 0, so we can bring down x squared. On the right, 0 plus 36 gives us 36. Notice we now have x squared by itself. Okay. To undo the exponent 2, we want to take the square root of both sides. I want to take that to the side. So we have square root of x squared. We're looking for a value times itself that will give me x squared. That's going to be x times x. There's my pair. I take one out. They both cancel. So on the left, we have just x. On the right, we have the square root of 36. 36 is a perfect square, which means that 6 times 6 will give that to me. And there's my pair. We take 1, 6 out. They both cancel. The only thing here we hadn't talked about previously, but another possibility to end up with 36 is if we take negative 6 times negative 6. So when you take the square root of a number, you want to take out not only the positive, but the negative version of it as well. So the square root of 36 will be positive and negative 6. If you wanted to separate the answers, you can put x equals 6 and x equals negative 6. That would be correct. Also, that would be correct. It's entirely up to you if you want to separate the answers or not. You don't have to. All right, 2a, x squared minus 9 is equal to negative 18. Again, we want to get the x squared by itself. The negative 9 is in the way, so I'm going to add 9 to both sides. On my left, negative 9 plus 9 is 0, so I can bring down x squared. On the right, negative 18 plus 9 gives me a negative 9. We have the x squared by itself. Now we can undo that by taking the square root. We already know from the previous example that the square root of x squared is just x. Now we're going to take the square root of negative 9 to the side. I would convert that right away to square root of 9 times the square root of negative 1, so that I remember that there's going to be an I, an imaginary number, in my answer. Square root of 9, 9 is a perfect square, which means it's the same thing as 3 times 3. There's my pair. I'm going to take out plus or minus 3. And then square root of negative 1 is just I. So the square root of negative 9 is going to give me plus or minus 3i. That would be an acceptable answer. If you want to separate it, you can tell me x is equal to a positive 3i and x is equal to a negative 3i. 3a, x squared plus 5 is equal to 0, same as before. We want to get the x squared by itself, so get rid of the positive 5 by subtracting 5 from both sides. On my left, 5 minus 5 cancels, giving me just x squared. On the right, 0 minus 5 gives us a negative 5. Then we undo the squaring by taking the square root from both sides. Again, from a previous problem, we know that the square root of x squared is just x. On the right, I'll take that to the side. Square root of positive 5 times the square root of negative 1. 5 is a prime number, so we won't be able to take anything out. But we know that whenever we take the square root of a number, we should end up with positive and negative. We'll leave 5 underneath since it has no pairs to come out. And then the square root of negative 1 means we can take out an I. So x will be plus or minus I root 5, which I would accept. If you want to separate that and tell me that x is equal to positive I root 5 and x is equal to a negative I root 5, that would also be acceptable. Example 4a, x squared plus 8 is equal to 0. Just like before, isolate the x squared by getting rid of everything else. Positive 8, so we're going to subtract 8 from both sides. On my left, 8 minus 8 is 0. Bring down the x squared. On the right, 0 minus 8 gives us a negative 8. We'll undo the squaring by taking the square root from both sides. On my left, we know that's x. On the right, I'll take square root of negative 8 to the side. Positive square root of 8 times square root of negative 1. 8 can be broken down to 4 times 2. 4 can be broken down to 2 times 2. Bring down the 2 from before. We have a pair, so 1, 2 will come out. They'll both cancel. This other 2 doesn't have a pair, so it will stay inside. We know that whenever we take the square root of a number, we end up with positive and minus. And then the square root of negative 1 is I. So the square root of negative 8 ends up being plus or minus 2I square root of 2, which again would be acceptable. If we separate it, that gives us 2I root 2 and negative 2I root 2. All right, example 5a, 9x squared plus 25. We want to isolate the 9x squared, so we get rid of the positive 25 by subtracting it from both sides. On my left, 25 minus 25 is 0. Bring down 9x squared equals, on the right, 0 minus 25 gives us a negative 25. We want the coefficient of x squared, the number out front, to be 1, which means we want to get rid of this multiplication by 9. So we're going to divide both sides by 9. 9 divided by 9 is 1. We're left with x squared. On the right, we just have a negative 25 over 9. Now we can undo the squaring by taking the square root. On my left is x. On the right, I'll take that to the side. So we have the square root of negative 25 over 9. I'm going to do that positive 25 over 9 times square root of negative 1. When you're taking the square root of a fraction, it's the same as if you were taking the square root of the numerator and the denominator. Square root of 25 is a perfect square, so that's going to give me 5 on top. Square root of 9 in the denominator, perfect square, so that'll give me 3. I know that whenever I take the square root of a number, I should end up with positive minus, and then the square root of negative 1 is I. So x will be equal to a positive or minus 5/3 I. If you want to separate it, that means x is positive 5/3 I, and x is equal to a negative 5/3 I. All right, example 6a. We want to get this by itself. We can't do anything inside the parentheses until we undo the square. So let's isolate it first by getting rid of the positive 53. So I'm going to subtract 53 from both sides. On my left, 53 minus 53 cancels. I'm left with the quantity x plus 2 squared is equal to 17 minus 53 should give you a negative 36. And again, we can't do anything to the x, to that quantity in parentheses until we get rid of the square. So we're going to take the square root of both sides. I'll take both of those to the side. Let me work on the square root of the quantity x plus 2 squared. Remember that the exponent 2 just tells me to take the base and multiply by itself 2 times. So if I expand it or rewrite it, x plus 2 squared is the same thing as x plus 2 times x plus 2. Remember, my index is 2, so I'm looking for pairs of 2. Here's my pair of 2. So I'm going to take one of those out, which means they both cancel. And because I no longer have the parentheses or the exponent 2, I don't need the parentheses, so I can just write it as x plus 2. Square root of negative 36, I'll take that to the side, is the same thing as positive square root of 36 times the square root of negative 1. 36 is a perfect square, which means it's 6 times 6. There's my pair. I take one out, they both cancel. Whenever I take the square root of a number, I end up with the plus or minus. And then the square root of negative 1 is I. So square root of negative 36 is just plus or minus 6i. Almost done. We need to get x by itself. So we're going to subtract 2 from both sides. On my left, 2 minus 2 cancels. We bring down the x. On the right, we have negative 2 plus or minus 6i. Keep in mind, negative 2 is the real part of my answers. Plus or minus 6i is the imaginary part. That's what we call a complex number. So just to review, complex numbers are written as a plus or minus bi, where a is your real and bi is the imaginary component. So I'm going to want to bring down the negative 2 first, and then plus or minus 6i. So that would be my answer. If we separate it, we'll get x is equal to negative 2 plus 6i, and we'll get x is equal to negative 2 minus 6i. Again, you don't need to separate it. Sometimes it's helpful just to remind yourself that there are two solutions.